This video shows how teachers can engage students in debating opposing hypotheses. Task, talk, and tools play a critical role throughout this lesson. As you watch, observe what kinds of tasks students are engaged in to make their thinking visible. What tools help students communicate their ideas? And how do particular talk moves facilitate students' comparison of ideas? Throughout this unit, students have been learning about how a flashlight works. They have collected observational evidence and are reasoning about how energy travels. This lesson was not part of the original unit plans, but rather the teacher added it because of a disagreement at the end of a prior lesson where students drew diagrams of how they thought current flowed in a flashlight circuit. While sharing their diagrams, the teacher and students noticed there were two different ways most students were thinking about how current flowed. This next clip shows how the teacher summarized the opposing ideas students shared the day before, and how she organized the task of having students communicate about these opposing ideas in more detail.
So we noticed a couple of different things. And let me do this. Let me choose a couple of spokespeople for these two different big different theories. I'll say what they are. One theory is that the energy enters the light bulb, I guess in two places is what people were thinking. That the energy comes like this, goes up the support wires, and collides there. And does something, and there's different ways of talking about what it does here in the filament, but that it's coming up both sides and then it's like clashing. If you're somebody who could make it make sense to the class, like you have a way of reasoning that theory, that it comes up both sides, you have a way of explaining that you would like to share. Think about doing that just a moment. And then there's the other big idea, the other big theory that's different, and they're not, they're opposing theories, right? It's like it's either one or the other for this model. Is the other theory is that it doesn't work where they come up both sides, they enter the bulb both sides. Instead, they enter, we don't know which one really, but one of these, and then goes the filament, and then goes out the other.
And around the wire back to the battery.
Right?
Yeah. So it's more like a round and a big.
And there's also the.
So it's kind of like a one-way street. The first one's kind of like a two-way street. A two-way circuit or a one-way circuit.
Oh, I like that.
Yeah.
But the rubbing theory, could that be part of either one?
So let's hear. Would somebody like to be a spokesperson for the two-way?
I think Jeanette, well, I know Jeanette was talking about one of them earlier. So.
Is it two-way you were thinking? Okay, so Jeanette, come on up and explain two-way. And Molly, if you want to add to hers, you can, okay? Because you both had two-way. The two-way.
But, yeah,
and then who would like to explain how they understand the one-way? The one-way. Colin, do you want to do it? And Ollie, would you also help if you need to add to it?
Students use a large but simple diagram to facilitate their explanations. Public representations facilitate student talk and thinking about science ideas. For example, they can provide reminders about the evidence students have collected, like the poster shown on the right, or a simple diagram can serve as a model when students gesture towards different places as they communicate their thinking. In this next clip, notice how students use the simple diagram as a model to help them communicate their reasoning about how current flows in a flashlight circuit.
First it goes through here, I'm showing the circuit, it goes through the
support wire.
Plus one. Then it goes down here, goes around this thingy, and then goes up the negative, and then it goes back through the D cell.
Pushes it back out.
Yeah. Questions, comments?
Before you take questions and comments, can I add one more thing that I'd also like to hear from the other theorists or hypothesizers. What do you think about the function of the glass bead? Do you have an idea about the function of that?
Yes.
Up there, hold on. Go ahead, guys.
I guess the glass bead is just holding it there so that if it was shook around, it wouldn't like fall over. Because these are support wires.
And the support wires have a glass supporter.
Yeah, so hold it together, and yeah.
Holly, did you have an idea about that related to the circuit? I thought you talked about that.
Oscar. I think the glass bead, like the bulb, it's actually for an insulator, so that like the energy doesn't like jump from one wire to the other somehow.
Oh yeah.
Because the bulb is glass, it's an insulator, so the energy doesn't like burn the outside. We could actually do an experiment about that. And the glass bead is maybe the same. We could have like another copper wire on the side with the battery and see if it jumps to the side. So the glass bead is like just there to make sure that the energy stays in its wire. It's like insulator.
By allowing students to lead classroom talk, students become resources for each other rather than the teacher being the source of knowledge. Students in this class are accustomed to using discussion sentence starters like the one shown on the left. In this next clip, notice how the two boys work together to address questions from their classmates about their hypothesis.
I agree with you about that. I agree with Oscar that the glass bead acts as an insulator, so the electrons don't jump from wire to wire. I sort of disagree with that because the glass circle, the glass bead, doesn't cover all of the wire. Yeah,
But it did in the big bulb, didn't it?
Is that it like ends here?
Well, yeah, I know.
But where the glass bead is that it's one of the closest points where the wires touch.
Or could touch.
And then the support wires kind of like they go like that. It might be both. Like it might support. It might like if it was just those, then you could like stretch it around and filament.
I sort of agree with Molly a tiny bit, where the light bulbs. Well, I agree with both Molly and Emma that the metal on this side are evaporated and it got sort of burnt on its way, so the glass is burnt and.
As students presented key points, the teacher summarized them and wrote them on chart paper. This public representation keeps track of the ideas that have been shared and helps students match evidence to them. If the class does not have evidence for a particular idea, an additional activity could be added to help students reason about their idea in a more concrete way. This next clip shows how students suggest their own tests to gather evidence they think would help support their key points.
But then another thing for your experiment, we could break the glass, but still have all the stuff intact so it can still work, and then take out the glass bead and see if it would work.
With wires.
I call breaking the
In a whole class debate activity, it is difficult to hear from every student and have time for multiple exchanges to challenge opposing ideas. To engage all students in intellectual work, break up the whole class talk by varying communication tasks. After students presented each hypothesis to the class, the teacher provided students with time to write about which hypothesis they agreed with and why. This clues the teacher into how students are thinking about the debate, even if they aren't the ones presenting. As a final task, the teacher asked students to draw a circuit of their choice and draw a write about how they think the circuit flows now that they have discussed claims and evidence over several days. Let's revisit the tips about the kind of talk tasks and tools that help students compare and challenge opposing ideas. Seize teachable moments when students disagree about a key science idea, particularly when it directly relates to district standards. Create written public records of a science activity to be used as a reference. A simple diagram can turn into a model as soon as students use it to explain their ideas. Let students take charge of classroom talk. Be explicit about the discussion norms and how to be a respectful participant. Tools like sentence starters also help facilitate student talk. As students share their ideas, the teacher acts as a recorder to create a public record of the ideas that are in play. Varying tasks from whole group talk to partner sharing and notebook writing provides time for all students to not only share their personal thinking, but also to come up with challenging questions or counterexamples for each side of the debate.